Hello and welcome to this video on FTIR. FTIR, also known as Fourier Transform Infrared Spectroscopy, is carried out to identify functional groups of organic and inorganic products. We can also use this technique to identify compounds by matching their spectrum obtained with a known spectra of reference materials. Firstly, the IR source. As the name suggests, this provides IR radiation that passes through a slit that blocks out stray radiation. This beam then reaches the interferometer. The interferometer. This component has fixed and moving mirrors that create a difference in path length of the IR beams. It causes the beams to interfere with one another, resulting in an interferogram. This beam then passes through the sample holder and reaches the detector, which records the intensity of the beam transmitted from the sample. Signal is amplified and the converter converts the interferogram to a spectrum using the Fourier equation. This spectrum is then displayed on the computer. Finally, the computer. It is used to do baseline correction and ATR correction if needed and match the resulting spectrum to the known reference spectra. Personal protection equipment. Before we begin, ensure that you are wearing lab coat and latex gloves for this particular experiment. Sample preparation. The following steps are done with regards to ASTM standard E1252 and E573 for ATR, materials and equipment. In the KBR pellet technique, we would be using the pellet die set consisting of the pellet, the bulk press, and the press system. We would also use the mortar and pestle, the hydraulic press, and KBR and sample powder. The pellet die set together with the mortar and pestle must be cleansed with absolute ethanol. After this, wipe them dry using tissue. Latex gloves must be worn to prevent chemical spills on skin and grease from staining the equipment. Tare the weight of the mortar and weigh the KBR and sample powder. According to ASTM E1252, the ratio of the sample to KBR powder should be in the range of 1:50 to 1:1000 depending on the type of sample. In this experiment, we are using 250 mg of KBR with 1.5 mg of sample. Powder can be placed in the oven if there are traces of moisture in them. Now, grind the powder till a homogeneous mixture of even powder size is achieved. Ensure powder is not too small as KBR is hygroscopic and will absorb moisture from the surroundings. Carefully transfer all the powder into the cavity using the scoop. Slide the bolt press into the cavity and rotate it to distribute the powder evenly. After this, push the upper pellet into the cavity with the smooth side facing down. Now transfer the die set into the hydraulic press. Be sure to close the shield before lowering the piston. This is an engineering control. According to ASTM E1252, the load applied depends on the diameter of the die. Spectra, the manufacturer of the pellet die set, recommended the load for the 13mm die to be 7 tons. However, we can apply 8 tons and hold the pressure for 3 minutes to obtain a thinner pellet. After this, release the knob anti-clockwise to return the piston and remove the pellet die set. Disassemble the die set, invert the upper body and place the set together with the adapter into the hydraulic press as shown. Once again, close the shield before applying pressure to remove the pellet. Now, disassemble the pellet die set, and voila! You have your sample pellet. Ensure the pellet is about 1 mm thick, as required by ASTM E1252. In a forceps, transfer the pellet into the sample holder.
Firstly, we will need to preheat our hot plate before sample preparation. It is needed to wear cotton gloves most of the time as we are dealing with polymer that can go up to very high temperature. It's classified under the personal protective equipment in the risk assessment as it can cause injury like scaling if not handled properly. Now, we will have to wrap the two aluminium foil into two small metal plates separately. Afterwards, we put two covered metal plates onto the hot plate using a forceps. Using the tweezer, put one of the polymer resin on top of the aluminium foil. Then we will have to wait for the resin sample to melt by observing the change from opaque to transparent, which takes quite a bit of time depending on the melt temperature of the polymer resin. Once the resin melts, sandwich both the cover plates together and transfer to the hydraulic press as quickly as possible. Once the film cools down, it will be difficult to remove it from the aluminium foil, which will be shown later. It's important to do things precise and quickly to get a good film produced. Ensure that the plate is centered properly so that it will have a direct contact with the metal plate. Wait for about 30 seconds as only a little pressure is needed to press the film. Release the piston afterwards, then take out the plate using a thermal glove as the metal plate is still hot. Peel off the aluminium foil slowly and carefully to ensure that the film is not cracked and stick together, as we want to ensure that all sample film is removed. Afterwards, put the film into the holder, then transfer it to the FTIR machine in transmission mode. Start scanning the machine and the spectra will be obtained. The spectra obtained will help to determine the polymer resin unknown.
Set up PerkinElmer 2 FTIR in transmission mode and open the software. After this, run a background scan of the air. Now run a scan of the sample as shown. After obtaining the spectrum, do a baseline correction as shown and click search. This would match the spectrum obtained with the reference spectra to identify the polymer that the sample is made of. In this technique, we were analyzing polyethylene powder. A typical spectrum of polyethylene is shown. We can observe that polyethylene has strong peaks at wave numbers shown in the table. These peaks are characteristic of the CH bending and stretching motion in polyethylene structure. Such peaks are also seen in the spectrum we obtained. However, they are not very resolute. This could be due to the air gaps present in the pellet prepared due to uneven distribution of powder size, which leads to scattering of IR radiation. To achieve better results, we could use the vacuum pump to remove moisture before pressing and apply lower pressure to form the KBR pellet.
Attenuated total reflectance. With ATR, no sample preparation is required. To start off ATR analysis, firstly swap in the ATR accessory. Next, clean the crystal and the tip of the force gauge using Kim wipes. Run a background scan of air. Then, place the sample with the side that you want to scan facing down. Rotate the force gauge above the sample. Click Scan. Rotate the force gauge until it reaches 80 on the reading. Click Scan again. After scanning, do a baseline correction and ATR correction. ATR correction converts the ATR spectra to a transmission spectra. Click Search to find out the closest match of the sample. We can see that the graph has similar results to that on transmission analysis, and that it has an 84% match with polyethylene with a 0.945 density. It has the same peaks in the same regions.